Okay, so we have this trigonometric identity, and we want to verify it. So the first part that we have here is sine squared x minus 1. And that looks a lot like a certain identity that we know. And we also know that there's a tan x on both of these, right? So I'm going to write sine squared of x minus 1. And then I'm going to factor out a tan x from here. So I'm going to say over tan x times 1. It's going to be actually times sine of x minus 1. Excuse me. Okay, so then, and then this is equal to sine of x plus 1 over tan of x. And we know that 1 minus sine squared of x is cosine squared of x. So then if we look at this here, we know that sine squared x minus 1 is really negative 1 plus sine squared of x. And we can rewrite this as negative the quantity 1 minus sine squared of x, right? And like I said, we know that 1 minus sine squared x is cosine squared x, right? So this is really going to be negative cosine squared of x. So we can put that for this. Okay, so we have negative cosine squared of x over, and then it's going to be tan of x times sine of x minus 1. And then this is equal to sine of x plus 1 over tan of x. And so we know that if we do cross multiplication, we get negative cosine squared of x times tan x equals sine of x minus 1 times sine of x plus 1 times tan of x. And so this becomes negative cosine squared of x tan of x equals sine squared of x minus 1, because we use the sum and difference pattern, a squared minus b squared equals a plus b times a minus b, right? So then this gets multiplied to times tan of x. And so then we know that sine squared x minus 1 is negative cosine squared of x. So really, negative cosine squared of x tan of x is equal to, and this is negative cosine squared of x, and then times tan of x. So that is how you verify this trigonometric identity. Okay.